is recorded for the group project of Principles of Information System class. We are group 63 and our group members are me, Algin Junali,
Mavlana Manov. In this video we will construct AND or NOT logical gates video. Also we will construct NAND gate with theme 47.
Hello again. Today I will be demonstrating the construction and the main principle behind the NOT gate, which is one of the basic logic gates. The NOT gate just operates the function of negation, which means that if we input 1 as a value, the output should be 0, or vice versa. To construct the electrical circuit of the NOT gate, we will use the transistor as the main element of the circuit. As you can see, we will use only one switch. It means that we will have only one input. We can divide the electrical circuit to two distinct parts. Part 1 we can call the one with LED, so when the switch is off, the electrical current just passes through the resistor located on the top left part of the circuit, and then through the LED, and the LED lights on. When the switch is on, however, the current passes through the resistor to the transmitter, then it enables the current to pass through the second part of the circuit. In this case, transistor blocks the electrical current to pass through the LED, which in turn makes the LED to turn off. So at the demonstration part, you can see that the construction process is successful. When the switch is pressed on, the light turns off, and vice versa.
Hello, my name is Mavlana Manov. Now I'll construct AND gate. The core principle of AND gate is that the output is high if both inputs are high, but the output is low if only one or none of the inputs are high. First, I'm setting up the inputs by placing two push buttons on the breadboard, which will serve as our input A and input B. Next, I'm adding two current limiting resistors that connect our push buttons to the bases of the NPN transistor, which I will place. These transistors act as our primary electronic switches. Now for the critical AND logic, creating the series of connection, I'm wiring the emitter of the first transistor to the collector of the second one. This ensures current can only pass through if both transistors are turned on. Then I'm connecting the third transistor. This transistor is used to control the final output to the LED. When the first two transistors are off, the third transistor receives the necessary voltage and is turned on. But otherwise, when they are on, they pull the voltage away, which turns the third transistor off. When the third transistor is off, the current is forced to flow through our output LED, illuminating it. Now, let's test this out. If I press only one button, the light stays off, but if I press two at the same time, the LED turns on. This was the construction process of AND gate. Thank you.
Hello, my name is Kemal Tagiev. Firstly, I'm going to plug in our buttons, which will be the OR gates inputs A and B. Then I'll add resistors for each button that will be connected to transistors in the future. Now, through those resistors, I'll connect the base of the first transistor to input A and the base of the second transistor to input B. The transistors will act as electronic switches that turn the output on or off depending on the input. Finally, by connecting the transistors to the positive voltage through a resistor, I'll give my turn to my colleague.
Hello, I am Zayev. Now I will continue the construction process First, I placed the output transistor. This component is essential because it acts as a control switch regulating the current that flows to our indicator. Next, I installed a 330 ohm resistor. This is vital to protect the LED from being damaged by excess current. Then I used jumper wires to finalize the connections among all components. Finally, I placed the LED to get our visual output. Here also I used jumper wires to create connections. Construction is now complete. When we press one button, the lights turn on. When we press both buttons, the lights also works.
To create NAND gate, we collaborated with Team 47. NAND, not AND gate, is a logic gate which produces an output which is false only if all inputs are true, which means opposite of AND gate. We, Team 63, connected our AND gate with Team 47's NOT gate to create NAND gate. First, we removed NOT gate's push button from the input and connect AND gate's output to the NOT gate's input. Then we connect two wires to the second breadboard's power rails from the first one to create current on it. Now let's test this gate. When we press both buttons at the same time, the LED turns off, but it stays on otherwise.